Hiya pirates, here we are. We're going to do some basic thermodynamic stuff. So remember that most of this stuff you have seen in your first year of chemistry. So I'm going to kind of go through it at a bit of light speed here, assuming that you can knock off some of the dust and rust of some of these problems. If I'm speaking Martian here to you on this stuff, let me know in a class period, and I can get to a breakout session with you and go through this a little bit easier with you in person, right? But if you're okay with this, then here are some of the ideas here for these basic heat ideas. So remember, we have three equations that we are going to use. The first is Q equals mc delta T. mc delta T. The second one is Q is equal to M times L. And then the third one is Q lost equals negative Q gained. So that is our calorimetry question. So you need to know which one to use, and you can tell just by the context clues that the problem gives you. And so this one here, all we are doing is heating the substance up. It doesn't say anything about melting or boiling or phase changing. It doesn't say anything about exchanging energy. So this guy here is just a simple Q equals mc delta T problem. Obviously, Q here is our heat or our energy, and it's usually in joules or kilojoules. M is our mass, usually in grams. C is the specific heat capacity, sometimes just called the heat capacity, but it's usually called the specific heat capacity. It's usually in joules per gram degree Celsius, but they might list it as in joules per gram Kelvin. And in these problems, it doesn't matter whether you use Celsius or Kelvin because of the fact that we're using delta T. And remember, in delta T, the degrees Celsius and Kelvin are the same. Again, if you're not sure about that, then check the lecture on this. So all we have to do then is fill out our very simple equation here, which is Q is equal to mc delta T. It wants the energy, so Q is our X. I've got 300 grams of water. I got a specific heat capacity of 4.18 joule per gram degree Celsius, and I got a temperature change of 58 degrees Celsius. So then my Q is going to be 72,700 joules, or if you prefer for kilojoules, because once those numbers start to get very big, they use the metric prefixes. It's just going to end up being 72.7 kilojoules there. Now, the second part of the question says, what if it were aluminum instead of water, right? Well, the only thing that is different is that aluminum has a specific heat capacity of 479, whereas the specific heat capacity of water is the 4.18. So literally, the only thing that you have to do for the second part is to change that number to the 0.479 that they give you for the aluminum. Everything else is the same. So the Q of the water was that. The Q of the aluminum then is going to be equal to 8,300 joules, or it's going to be 8.3 kilojoules instead. So that is that. So the Q for the water is that, and the Q for the aluminum is that.